Welcome to another Ramda video, and this time we are going to talk about the function cond, which I guess stands for condition, or maybe condensation, not as in condensation as in water, even though the example here that they use is in terms of water or is in regards to water, but probably condensation as in condensing down to a single value. But now I'm totally making stuff up, and it's highly likely that this isn't actually true. So probably what it sort of refers to is condition, because what is the function cond? I mean, we'll read the type definition and we'll read the description in just a moment, but I mean, think about it this way. Cond is what most of us know as a switch statement, a switch case statement, right? When you say, I have this variable and I don't know whether it's this thing or this thing or this thing, or whether it satisfies this condition, or this condition, and depending on which one it does, which one it satisfies, I want to do different things. That's essentially cond, right? But it's the functional equivalent. It's the functional programming version of that particular thing. So yeah, I mean, I guess we'll have to talk sort of about the... we haven't talked yet about if-else, right? But there's also an if-else equivalent. And probably it's easier just to talk a bit about if-else. So maybe we start in that end. And actually, so let's just jump in here, right? And let's open up the file main.js that we've worked with before, and let's just start by requiring Ramda. So let's require Ramda. And then let's just console log this R just to see that we have require Ramda appropriately. And let me just map a keystroke to running node on this particular file so that I can quickly run it. Okay, we run that and we can see that we get all the functions of Ramda. So clearly, so far so good, right? But okay, so now we have some place where we can write code. And actually, before I read the definition of cond and before we look at the type definition, let's start by talking about a switch statement, right? So a switch statement in JavaScript, let me try to remember what this is like, right? So let's say that you have this variable called, let's say, well, I don't know, let's say age, right? Or I don't know, whatever. Let's say, okay, there's a variable called name, which is John, right? And then we want to switch over John, and we want to say, well, depending on what the contents of the name variable is, we want to do different things. This is really a silly example. Yeah, okay, but whatever. Let's do that, right? So then you would write a number of different cases, right? So you would say, okay, well, if the case is such that the name of the person is John, we want to do something such as, for example, we console log hello world John, right? And let's say that the default case, in other words, oh, sorry, I need a break statement here so that doesn't sort of trickle through. And also, I mean, from that perspective, I should mention cond is not exactly like a switch statement, because it seems to me that you don't have this sort of fall through mechanism where if the first one is satisfied then you don't break, but then the second one is satisfied as well, then you get sort of the effects of both, right? Because in functional programming you don't have side effects in this way, but we'll talk a bit more about this, right? But then let's say the default statement is hello unknown. Okay, so this kind of makes sense, right? So it's like we're saying, well, we're hard coding in the fact that we know John. Let's hard code in the fact that we know somebody called Jane, right? And then we'll say console log hello Jane, right? So let's remove world. This doesn't make any sense. Let's make that a capital letter. Doesn't really matter, but whatever. And then let's just say break here. I don't actually think I need these, so let's skip those. And here we don't really need a break statement, but let's just put a break statement, right? And yeah, this is sort of a fully functional program. So let's run that, and we'll see what we get. And we get like the result is hello John, right? Hello John here, okay? Because we had John in the variable. But if we had Jane in the variable, like so, then we get hello Jane. And if we have someone else in the variable, right, then we get hello unknown person, right? I mean, this is a switch statement. The thing is, of course, that notice how we're console logging in these switch statements, and that's a side effect, right? So that doesn't really work when we are in the world of functional programming. And I think more evidently, or not more evidently, but perhaps more simply, we should think about this in terms of an if statement, right? So you have this condition, right? So it's like, if this condition, then do this thing, right? And then you have, okay, well, else, otherwise, right? do this other thing, right? And you could think about this as if this condition, so it's like we're executing these statements, right? We're executing these statements, and then we're saying that if the condition is true, then execute all the statements in this block, right? And when I say in this block, I mean from this point, from this squiggly bracket to this squiggly bracket, right? And if it's not true, then execute all the statements in this other block, right? Which is everything from this squiggly bracket to this squiggly bracket. So actually here you could have any number of side effects. You could say, well, I have this variable called a, and I'll assign b, or I'll assign 10 to a, right? And then I'll console log a, and all of this stuff, right? Like you can have, or like write to file or whatever. You can have any number of side effects, okay? But when we're in functional programming, this isn't really the way we should think about if else. The way we should think about if else is that, well, I mean, everything needs to be a function, right? So if everything's a function, then it has input and it has output. So if else also needs to have input and output. So if else is a function that first takes a condition, right? Then takes the true block, let's say, the thing that it should do if the condition happens to be true, and then it should take the false block. So the block that we should execute if the condition happens to be false. And instead of cond, let me just actually write condition here, right? And of course it's not a block, right? Because as we just said, that when we think about things in terms of functional programming, we shouldn't think about them in terms of blocks. It's not about like executing a number of statements. It's about computing a function and returning the result, right? Like whatever the function yields. So instead of saying block here, we should probably say function, right? Like true function and false function. So we'll talk about this a bit more in detail when we get to if else here in Ramda, but I think what they do is something like this, where condition is a function, or actually let me put it this way. So this would return a if-else function, let's say, right? And this if-else function, you can pass some x, and this x will be passed first into the condition, so the condition has to be a function. So does x satisfy the condition? So this condition is a function, and if it does satisfy that, then the x is passed into the true function, and we expect the true function to yield the result as a consequence of being passed x. But if the condition, if when x is passed to the condition yields something which is falsy, then we pass that x into the false function, right? So it's not like, so this is why we're saying this is a true function. It's not a true value, and this is not a false value, right? So it's not the value that we should return when the condition is false, or the value that we should return when the condition is true, right? And also the condition is not it's not a value, it's not a Boolean, right? It's a function that when given some value yields a Boolean, right? And then we pass that same value to the true value, or the true function and the false function. So the reason I'm saying that is that the switch case here, or the cond function, is just a more complex variant of this, right? Where we're saying, so let's remove this if-else stuff, right? So you can actually think of it this way, right? So it's like this is the non-functional way of doing it, right? And this is the functional way. Right? So we've sort of translated it, okay? So so how do we translate this switch function then, right? So this is then the non-functional, I should probably say like imperative or procedural, but like let's say this is the non-functional way, and then let's convert this. Like, what would the functional way of doing that be? Well, it would be something like, and now we'll start using the syntax from Ramda, right, from over here, but we won't use it specifically. I'll sort of use pseudo syntax for now, right? We would do something like, let's say that the function is called cond, right? Just like we said, let's call the function if else and pass a condition, right? Now we need to do something like, we call this function cond, which could be a switch case, right? And then we pass an array of different conditions. And this array of different conditions is the cases, right? It sort of corresponds to the cases. It's like, well, you need to specify that one case is John, and then one case is Jane, and one case is every other case, right? And these have some consequences. So it's like it's like pairs of case consequence, right? The case John has this consequence. The case Jane has this consequence. The default case has this consequence, and so forth, right? So we're expressing a number of pairs, and this is why they're using an array here. So they're using an array to denote a pair, which is actually a bit funny, but it's because of the quotation marks, in this case, like limitations of JavaScript. Like you can't, there's no pair type in native JavaScript. Like for example, let's say in Haskell, you can actually have a pair. Like you can have something that strictly has a thing at the first location and a thing at the second location, and the thing at the first location is of a particular type, and the thing at the second location is of a particular type. But in JavaScript, we have arrays, right? So they're just using arrays here to behave as, or using them as if they were a pair type. So like index 0 is the first item and index 1 is the second item. So anyways, what we would do is we would simply say, well, I have some condition, let's say condition A, and then I have consequence A, or effect A, or whatever you want to call it, right? And then you can duplicate this. Okay, so we'll copy that, and we'll say, well, this is condition B and condition C. Condition C, and then this is consequence B, and this is consequence C, right? And then it's a question of, well, what are these, right? So let's think about one of them, right? So the pair, actually, let's think about it this way. The condition is a function that, when given some value, or actually maybe in the way they usually express it, maybe it's a variadic function. It's like when given some number of values, it yields a Boolean, right? And what about consequences? Well, consequences, let's say all the consequences, they must also take any number of arguments of any type, and they mustn't yield, or sorry, mustn't means that it cannot, but I mean, it doesn't necessarily have to yield a bool. It could yield anything, right? And think about this, because this is the same structure that we had in the if-else case, right? So the condition takes a number of arguments, like when passed the x, will have to yield a Boolean. So when the condition is passed the x, it has to yield a Boolean. But then the consequence, let's say the consequence of true and the consequence when false, right? Those are functions that when passed the same value, right? When passed the same x, they can yield anything that you want, right? Because that's the thing that you want to return. So let's be a bit more clear here, right? So if we use some concepts from Ramda, you could say something like R equals John, let's say, right? And then we return something, and then they use, in the example here, they use R.always, right? And R.always, I think, is like the constant function. So the constant function is, let's say, if we call it k, right? The constant function is something that takes one argument. I'll just call it underscore. Takes some x and then some other argument, I'll call that underscore, and just returns x. So that means that when you call k with, let's say, foo, you get a function that, regardless of whatever you pass it, you will still get back foo, right? So it's a constant of the first value that you pass it. So that's always, right? And the reason we use always here is because the consequence is not dependent on the value that was passed to the condition, right? Like we're passing in some x where this x might be equal to John, for example, but whether it's equal to John or Jane doesn't matter in terms of how we produce the output value, right? When it's like we've already hard coded it so that if the condition equals, if the value that we pass in equals John lowercase, then we should return this string hello John, right, as a consequence. So let's put all of these, right? And if it equals Jane, then then we should always return, or we return the constant function, or we employ the constant function that returns the string hello Jane. And then how about default, right? So this needs to be a condition that's always true regardless of whatever x you pass it. And that's actually R.t, right? But it's not a strange function if you think about it. I mean, it's like we could define the, let's say, always true function, right? It's just saying that whenever you pass it something, you will always get true back, right? Regardless of what x you pass it, you will always get true back, which of course is the same thing, always true function, as saying that it's k of true, right? If we still had k defined, right? K is so x and then some other variable, but we still return x, right? So it's constant. It's the constant function over true. I'm probably expressing that incorrectly, but I think you see what I mean. So that's, I mean, that's r.t is essentially that. It's just a function that whenever you pass it a value, it always returns true. And then what's the consequence c? Well, that's r.always hello unknown person. Okay, let's line this up just so it looks a bit prettier like that, right? But yeah, and then cond we just made up, so let's now actually use R.cond. Oh, sorry, R.cond, and let's put that in some function. I'll just call it f for now, right? So f is equal to R.cond, where you have where we pass an array of a number of different case consequence pairs, right, or condition consequence pairs, where there are three conditions, right? The first condition is does the thing that you passed equal John? The second condition is does it equal Jane? And the third condition is, well, I don't care, this condition is always true, right? And then we pair those up so that if this thing that we pass in matches John, then we return or then we employ the constant function that will that is wrapped around the string hello John, so that regardless of the thing that we pass to the condition and that we will also then pass to the consequence, we still always get the string hello John. And then the same thing here, but for the string hello Jane, and then the same thing here, but for the string hello unknown person. So let's try to see if this works, right? So let's console log the running of the function f on the string John, let's say, right? And we should have two outputs because we still have the old output, right? And it actually works. Oh my god, right? So here we have hello unknown person because that was the output of this thing over here, right? We still have this thing, the non-functional, right? We still have the declaration of the variable name and then the running of that through this imperative switch statement where we end up by console logging hello unknown person because the name was equal to someone else. But then we also are outputting the oh my god, so many wrong buttons. Okay, then we're also outputting the result of running f on John, or running John through f. Where f is the result of constructing this conditional using Ramda here, right, based on these conditions. And you can see then that we actually do get, here in the second case, we do get hello John, uppercase John, so we know that it's not this thing, it's actually this string here. So and let's just try this out, right? We should be able to, let's keep this and then let's just output multiple ones. Let's say John and then la 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 la, or sorry, I mean Jane and then la 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 la, right? So now we should get all of them. So first hello John, then hello Jane, and then hello unknown person, because we're matching all of the cases. Now an interesting point, okay, this is an implementation detail of how they happen to implement cond in Ramda, is that if we remove this truthy case and just say that, well, okay, there are two cases, John and Jane, and then if there's something else, there's no specified behavior, right? Like the behavior is undefined. Then what do we get? Well, turns out what we get is undefined. So, I mean, it's not obvious what to expect here, right? Like it depends on the person who's constructing the library, what they do. And if you're in a statically typed language, what you might do is you might say that there are instances of the type that is expected to be passed to the condition that doesn't have a matching condition, right? So then you could probably statically figure out whether there are whether it's possible to not have a case that matches. Actually, I'm a bit confused now about whether that's true. Maybe that's not actually true. I don't know. If you spontaneously know whether that's true, please do shoot something in the comment section. That would be interesting. I guess in some cases it could be known, but I guess otherwise maybe languages would just enforce always having a default case so that there's always a path out, right? Because otherwise you might have an exception. But but yeah, so their decision is just that if you don't have any matching case, you'll just return undefined. But the way to construct your own default case is just by having one condition consequence pair that that is simply always true. And actually, I use the terminology condition consequence, which was unfortunate because I should have just read this first and noticed that they use the terms predicate transformer, right? Which is actually a lot more sensible, right? Because a predicate is something that, when given a value, is either true or false. So these are essentially predicates, right? Like R equals John, or equals John, the function equals John is essentially a predicate, right? Equals Jane is essentially a predicate. And transformer makes sense because it's transforming some input into some output, and in this case the input is the same as the thing that is passed to the condition or the predicate. And actually let's do that now as well. So let's say, let me remove this stuff, r.always hello John, right? Because we said that's employing the constant function because we don't care about what the input was. But let's actually care about what the input was. So I don't know, can you concat strings like this in Ramda? I can't remember. Like, I guess you can say concat hello comma space or something like that. Let's just see if that works. Yeah, so then we get hello comma lowercase John. Right? So notice how we're not specifying John here, but now we're partially applying the function concat so that it has its first argument, which is hello comma space, and then it's expecting another string that it will concat into that, and the string that it will concat into that is of course the thing that's passed, the x that's passed into the condition, f here, where that f where that x is the same thing that we're matching against, that we're running through the predicate to see whether this condition is true or not. I think I maybe expressed that a bit strangely, but I think you can probably see what I mean. Like, you're using R.cond, we're constructing a new function where we will match predicates, where we will check which predicate, the first predicate that matches, and then we will run the value that matched the predicate through the transformer, right? And that's why here, when John matches, when the predicate R equals John matches the string John that we passed in, then we run John, the same value, through this transformer, which concats the string John into into the string hello comma space, right? So, I mean, in my mind, it's pretty cool, right? So that's essentially the functional way of constructing a switch case statement, right? It's a way of saying, well, I have all of these different cases, and I want to do different things, or I want to return different things depending on which one it happens to be. Then you can simply sorry, I get very confused about the mic here. Then you can simply run that through. Then you can simply construct that function, and then you can simply use R.cond and construct a number of different cases, and then you will run whichever transformer. You will run the transformer that's paired up with the condition that matches the thing that was passed through. So super sensible, and if you have tons of conditions, this is a very sensible way of approaching it. Solid. I guess that's it. Oh, actually, sorry, let me just move the mic here. Not sure why that happened. Anyways, before we move on, let me just actually of course read the definition here, just emphasize that we haven't been saying anything that's completely crazy. So cond returns a function fn which encapsulates if else and so forth logic. R.cond takes a list of predicate transformer pairs, and all of the arguments to fn are applied to each of the predicates in turn, so upwards and down, or from the top down, so first one, second one, third one, and so forth. So if the first one matches, then it doesn't matter if the second one matches, because the first one matched, and that's the transformer that will be run, until one returns a truthy. So remember, right, a truthy value is not necessarily something that returns the or a function a function that returns, it's expecting a predicate that returns a truthy value, and a truthy value is not necessarily the value true, but it's something that in JavaScript is considered truthy. So I guess like 1 is considered truthy and 0 is considered falsy, if I'm not mistaken, right? But generally something like that, right? So whichever one first returns a truthy value, at which point fn returns the result of applying its arguments to the corresponding transformer. If none of the predicates matches, fn returns undefined, as we explored, right? And it's important then to realize also that they say applying its arguments here, right? So you don't necessarily only have to pass a single, as we called it, x. You can pass multiple arguments to this function f here. And yeah, let's look at the type definition. Now this looks a bit funky, but it's actually not that funky because there's just one input type and one output type, right? But this input type is a list of lists, right? But it's not actually a list of lists. It should actually be a list of pairs, right? As we talked about, like, but since we don't have the pair type, they use, or in JavaScript they use arrays here to denote the pair. So, and then you can see that the first value of the pair is here and the second value of the pair is here, and this part is the predicate and this part is the transformer. And the predicate, as we talked about, takes any number of arguments. It's a variadic function and it must return a boolean. It mustn't actually return a boolean, right? It must return something which is truthy or falsy, but you could consider that a boolean in JavaScript, I guess. And then the second argument in this pair is is essentially the transformer, right? And the transformer could be anything. It's something that takes these arguments that was passed to the same type of arguments that was passed to the predicate, but instead of returning a boolean, it just returns anything because that's the transformer, right? It returns whatever you want it to do. Okay, I hope that makes sense. And with all of that said, you can probably sort of trivially read the example that they have here because it's not greatly different from what we have as well. Solid. Thanks a lot for watching. If you're not already subscribed, remember to subscribe, and I will see you in the next Ramda video. Thanks for watching.